solving problems using trigonometry, compound problems. So I'll give you a moment to read this example. Okay, so here is our point A, and it is 10 meters from the base of a tree that has height h. I won't draw the whole tree because you know how dodgy my drawing is. I'll just go for a straight line. We're going to assume that the tree is going straight up perpendicular to the ground. The angle of elevation to the top of the tree is 36 degrees. From a point B, x meters further away from the base of the tree. So here's my point B. It's x meters further away from the base. This angle of elevation is 20 degrees. So that's part A done. I've drawn a diagram to illustrate that information. Now I need to find the height of the tree. To find the height of the tree, I'm going to use this triangle here. So first I need to label the sides with respect to my angle. Here's my right angle, so this is my hypotenuse. This is my reference angle, so this is my adjacent, and this is my opposite. I remind myself of SOHCAHTOA. In this question here, and you'll notice with angles of elevation and depression questions, we've got opposite and adjacent, so it's tan. Often, most of the time in fact, angles of elevation are going to involve tan. So we write tan theta equals opposite over adjacent. We substitute in. And remember to be careful. I've got two h's going on, so I don't want to get them mixed up. This is my lowercase h to mean height. Then here I need to multiply both sides by 10. And then I'm asked to find the height of the tree correct to the nearest tenth of a meter. So I put that into my calculator and I get h equals 7.3. Remember, the first digit after the decimal point is a tenth. So the height of the tree is 7.3 meters. Now I need to find this distance x, but I'm going to need to take a few steps here. So this is now my reference angle. My hypotenuse, I'm looking at this triangle now. My hypotenuse is opposite the right angle. This is my reference angle, so this is A. And again, I've now got three A's going on. Luckily, they're all in the same kind of place, but don't get confused here. This is my point A. This was my adjacent from my first question. This is my adjacent from my second question. Because this is my adjacent, this is my opposite. Now, I've got my SOHCAHTOA already. I want this distance x. Now, I can't find the distance x using this triangle here because this isn't a right-angled triangle, and I don't know how to use trigonometry in non-right-angled triangles. So that's why I'm using this bigger right-angled triangle. I know the height of my tree. I know that this length from B to the base of the tree is x plus 10. So I've got my adjacent and I've got my opposite. So as before, I write tan theta equals O over A. Now I substitute in the things I know. So my opposite is h. My a is x plus 10. Now I know h. I'm not writing 7.3 because I don't want to type 7.3 into my calculator. I need to use the answer I had before. So I'm going to leave it as h for the moment. I need to multiply both sides by the denominator. I need to be careful to write it in brackets because it's all one thing at the moment. So x plus 10 times tan 20. Remember there's an invisible multiply sign there. It's h. X plus 10 equals h divided by tan 20. So on my calculator, I've got my 7.265 that I calculated for h before. Now I want to divide that by tan 20. So I can just go straight to divide and the calculator knows that I'm telling it to do the answer divided by. Then we want tan 20. So tan 20, close the bracket, press enter. That gives me this value, 19.9616. Now that is x plus 10. I just want x. So for my final answer, I need to subtract 10. I can just click on subtract straight away and the calculator knows I'm telling it to subtract from the answer. And I type in 10 and I get this. I'm asked to find this distance to the nearest tenth of a metre. This is 9.96. To the nearest tenth, I need to have a look at this 9 and the 6 after it. The 6 tells me to round the 9 up. 9 rounds up to 10, which rounds this 9 up to 10. So this to the nearest tenth is actually 10.0. So if I move up to here, so I had x plus 10 equal to 19.961. Then I subtracted 10 from both sides, which gave me 9.961. Then I need to round to the nearest tenth of a metre, so x equals 10.0 metres. So I had to do two calculations. Oh, I don't know why I've gone so far forwards. Sorry. I had to do two calculations there. That's why this is called a compound problem. And that's what you will need to do for questions 17 to 20. Sometimes you have the diagram. In this question here, this should be theta. And here's questions 19 and 20. And here's your answers to all four of them. Let me know if you have any questions or you'd like me to go through anything. Thank you.